Hi, I'm Carrie, Parmenter. I work for the Posey County Soil and Water Conservation District. In our previous video, we had taken soil samples at a vegetable garden, and now we have the results from those soil samples. So we will be going through how to interpret your soil test results. Whenever you first look at the soil analysis, probably the thing that stands out the most is a graph that says soil analysis ratings. And if you look at the left-hand side of the graph, you'll see that it is separated into very high, high, adequate, medium, and low. And across the bottom of the graph, you will see all of the different chemicals that we have tested for. So we're going to go through each of those chemicals individually. We'll talk about what those levels are and whether they're adequate or low or very high. And then we will also talk a little bit about how to amend those so that your soils will be more productive. So starting on the left, you will see a P, and that is for phosphorus. Phosphorus is a nutrient that is one of the macronutrients, and phosphorus will convert starch to sugar. It helps with root development and cell formation, especially in young plants, and it helps with flowering and the formation of seeds. You can see that our phosphorus levels are in the low range, so we are definitely going to need to add phosphorus to the garden to increase that level. The next one is going to be potassium, and the potassium level is in the adequate range. And potassium is one of the macronutrients. Phosphorus, potassium, and nitrogen are our macronutrients, and those are the most important nutrients that we will be testing for in the garden. So potassium promotes stem and leaf growth. It helps with iron uptake, and it helps with disease resistance. Whenever you have low potassium levels, you're going to see yellow areas on your older leaves. And our potassium that we have in the garden is in the adequate range, so we might add a little bit of potassium just to help raise that up into the higher range. Because it is so important for our vegetables. The next one, the Mg, stands for magnesium. Magnesium is needed for chlorophyll production, and it is very high, so we will not need to add any magnesium for our garden. Calcium is the next nutrient, and the calcium is also very high, so we have adequate amounts of calcium. Calcium helps to strengthen the cell walls, and it helps with root formation. So both of those are in the very high range, so we will not need any amendments for them. If you go on down the chart, the next thing is going to be zinc. So the sulfur, boron, zinc, manganese, iron, and copper are called micronutrients. So the micronutrients are needed in much smaller quantities, but they're all still important. And you can see that our zinc levels actually fell into the low range. So zinc is very crucial for plant development. If you have low zinc levels, you will have discolored leaves, and you're also going to have stunted growth. So the zinc level needs to be raised, and that can be raised by purchasing zinc and adding it to the garden. Our copper level is actually in the medium range, and it is within the range of acceptable, so there's probably not necessary to add copper at this time. You will notice that there is an area that says soil pH and buffer pH. So the soil pH, we like it to be 6.5, so it is in the low range right now. And soil pH is one of the most important aspects of your soil, because the soil pH is going to determine how easily the nutrients can be absorbed by the plants. Down in the very bottom left, you will see that it says lime, and underneath is a recommendation of how much lime is needed for the garden. So lime is added whenever your soil pH is too low, because we want it to be 6.5, so we need to add lime, which is calcium carbonate, which is basic, so that will raise our pH. So that is why it has lime as a recommendation to add to the garden, is to help raise that soil pH. The other thing that we'll notice in the second line is called organic matter. The organic matter is only 1.18%, and that is a very low organic matter level. We want the levels to be between 2 and 5% for healthy soils. And the way that you would increase your organic matter is by adding plant or animal material. In a vegetable garden, one of the best ways to add that is through cover crops. So Miss Lashley could plant cover crops in the fall, let those grow all winter, and then in the spring she can terminate those, and then the plant material from those cover crops will be added as organic matter. So one thing that she should probably try to work on is increasing her organic matter. So next to the organic matter, you're going to see ENR, and that stands for estimated nitrogen release. That is a low number. We want it to be up as close to 100 as possible, and that is low because our organic matter percentage is low. So what that means is that since we have low organic matter, the nitrogen that is in the soil is not going to be released as well. So the higher organic matter is going to help with the nitrogen availability for our plants. So whenever we increase organic matter, then the ENR percent should increase also. So on the right in the middle, it says cation exchange capacity, and that's 14.2. So the cation exchange capacity is the soil's ability to retain nutrients. And 14.2 is in the acceptable range. It is a little low. The higher the organic matter is, the higher the CEC, which is the short for cation exchange capacities. The CEC will be higher with the higher organic matter. So by increasing the organic matter in the soil, Ms. Lashley would be able to increase her CEC levels. And that is how well the soil can retain nutrients. So the cation is a negatively charged ion that's in the soil, and it will attract the positively charged nutrients, that is like potassium and calcium and magnesium. And that's so since those are negatively charged and positively charged, then they can bond together and it holds in the soil and is more readily available to the plants. So you will notice underneath the base saturation that the H, hydrogen, is very high. And that is because our soil pH is very low. So that means we have more hydrogen in the soil. So the more that we increase our pH, the less the hydrogen percentage will be. And then that will increase our available nutrients, the potassium, magnesium, calcium, and sodium levels. So that is what the base saturation chart is showing you, is what percentage of each of those nutrients is available for the plants. So plants do not need the hydrogen as much, but they need the other nutrients more. So you want to decrease the hydrogen amount and increase the other availability. So down at the bottom, we see fertility recommendations, and they are recommending pounds per 1,000 square feet. So you would measure your garden to see how many square feet it is, and then these recommendations would be based on 1,000 square feet. So you'd have to do the math to figure out how many square feet you have versus how many square feet they are recommending. So they have lime, which we talked about, nitrogen, phosphates, and potassium or potash are the three things that are recommended. And those are NPK is what the acronyms for those are. And whenever you go to the store to buy fertilizer, you will see NPK listed on there. And those levels that are listed on there will give you an idea of how many pounds you're going to need to buy of each of those nutrients. So whenever you get a soil sample result and you have the recommendations, it is not very easy for a vegetable gardener to be able to just buy 2.3 pounds of nitrogen. Usually at a store like Lowe's or Home Depot, they will have them in pre-mixed bags that are a set rate per each of those nutrients. So the University of Georgia Extension has created a fertilizer calculator for homeowners. So we will be able to enter these recommendations into this calculator, and it will tell us which bag of fertilizer would be the best to put onto the garden and how many pounds of that we need. If you would like to go onto that website, you will be able to play with these results and see what type of recommendations you might be able to come up with using the soil sample results. So when you visit the fertilizer calculator website, you have to do a little bit of calculating to figure out pounds per acre, because that's how they want you to enter it into the calculator. So our nitrogen was 100.19. The phosphorus was 47.92, and our potassium is 78.41 pounds per acre. In the middle column, you will see that there are different types of pre-mixed fertilizer that you can choose from. And you can click the different ones and play around with that till you get one that gets your score as close to 100 as possible. And if you look down at the very bottom, you will see that the recommendation comes back as 11 pounds of 10-10-10 fertilizer. And that means 10 of the nitrogen, 10 phosphorus, and 10 potassium. That's the NPK. And then you also want to add 11.7 pounds of 10-06. If you would unclick one of those buttons, then your surplus or deficiencies would change, and you would see that you would need to add more nitrogen or add more potassium. So this would be the recommendation that we would make for Miss Lashley to add to her garden. And then in addition to that, she would also need to add zinc and lime to her garden. So if you would like to have some assistance with figuring out a soil sample results, or if you need assistance with taking a soil sample, you can contact one of the members of the Promoting Urban Soil Health in Towns group, and we have contact information on the screen so that you can get a hold of your local person.